Welcome to 5.3 Sum and Difference Identities for Cosine. We are going to work on example 4. Suppose that cosine S equals 15/17, sine T equals -24/25, and both S and T are in quadrant 4. Find cosine of S minus T. First thing you might notice is that we actually have two different angles going on here. So we have cosine S, so S is one angle, and then we have sine of T, so T is a different angle. Let's first go ahead and examine what we're trying to find. We're trying to find cosine of S minus T. So because we have subtraction inside the cosine, we're going to need the couscous formula, or cosine of A minus B. So we have cosine, cosine, sine, sine, and ST will stay in the same order. And then because it's a minus here, this will be a plus. And this is multiplication in between the two. I kind of spread it out a little bit much that time. So we're going to need 4 quantities as always. But in this situation, we need sine and cosine for S and sine and cosine for T. One strategy I like to use just to organize my work is I like to write sine and cosine and just kind of put in the table, and then I have S and T. So this is just to organize the information to see what I have and what I need. You don't have to do this at all. You could just plug it straight in here. So I might say, okay, for S, I am told that is cosine is 15/17. So S, the cosine is 15/17. Then I'm also told that sine of T is -24/25. So I'll put that here. In the sine of T is -24/25. So now we can see I need to find the sine of S and the cosine of T. So one way to do this is we could use our Pythagorean identities. I will go ahead instead and use the pictures, but know that another alternative is just to do sine squared plus cosine squared equals 1 for S, and then do the same thing, sine squared plus cosine squared equals 1 for T. So let's start with S. So we are told that cosine S is in quadrant 4. So this is my picture for S in quadrant 4. And then we're told that cosine is 15/17. So that means my x is 15 and my r is 17. And so now I need to find the y value. So I can do that using Pythagorean theorem. 15 squared plus y squared equals 17 squared. So here we will subtract 225 from both sides. Y squared equals 64. We do the square root and we get y equals plus or minus 8. Because we are in the fourth quadrant, the y value will be -8. So now to find sine S, it's y over r, or -8/17. Now we need to do the same thing for T, but we need a totally separate picture because it's a different angle. Angle T is in quadrant 4, but we have that the sine of T is -24/25. So now my y value is -24 and my r is 25. So now we need to find my x value here. So x squared plus -24 squared equals 25 squared. Now we subtract 576 from both sides. So we get x squared equals 49. We do the square root of both sides. Don't forget the plus or minus. So now because we are in the fourth quadrant, the x value is actually positive. So we get a +7 for x. Therefore, when we find cosine of T, it's going to be x over r, or 7/25. Now we are ready to plug in the values. For T, we have cosine is 7/25, sine of T is -24/25. For S, we have cosine is 15/17, and sine is -8/17. Because these numbers are larger, I don't mind if you use a calculator. 15 times 7 is 105. 17 times 25 is 425. 8 times 24 is 192. And again, 17 times 25 is 425. So we are ready to add these two together. They have common denominators. 425 is the common denominator, and we get 297 as the numerator. So our new angle, S minus T, has a cosine value of 297/425. I hope you enjoyed this video. See you next time.